Dive into Mind Syrup, your sweet spot for science and technology enlightenment.
What if the materials of the future could change their properties at will, adapting to our needs in real time? Picture this: materials that are more than just static. They are intelligent, responsive, and transformative. We're living in an exciting era of scientific discovery. The field of materials science is advancing at a rapid pace, pushing the boundaries of what we once thought possible. The materials we know, the ones we touch, feel, and interact with every day, are evolving. They are becoming smarter, more adaptable, more dynamic. Imagine a world where the fabric of reality can be manipulated, not in a science fiction sense, but in a very real, tangible way. A world where materials are not confined by their innate properties, but can be dynamically tuned to suit our whims and needs. Welcome to a world where materials are not just passive, but active and dynamic. Welcome to the world of metamaterials. Metamaterials are not just any regular materials. They are special, unique, and dynamic. Imagine materials that can change their shape, size, and even mechanical properties in the blink of an eye. Materials that can twist, bend, and morph according to our whims. Sounds like something straight out of a science fiction movie, right? Well, welcome to the realm of metamaterials. Metamaterials are a new breed of materials that are designed and engineered to have properties that are not found in nature. They are not a single material like steel or rubber, but rather they are made up of multiple components, which can be metals, plastics, or even gases. These components are arranged in specific patterns that give metamaterials their unique properties. Now let's talk about those unique properties. The most fascinating thing about metamaterials is that they can dynamically change their shape and mechanical properties in real time. Imagine a material that can become stiffer or more flexible at your command, or a material that can expand or contract based on environmental conditions. The possibilities are endless, but how do metamaterials do this? It all comes down to the design. The components of metamaterials are arranged in a way that allows them to interact with physical forces like light, sound, and heat in unique ways. This interaction can be controlled and adjusted, allowing the metamaterial to change its properties as needed. It's a bit like a symphony orchestra, where each instrument plays its part to create a harmonious whole. But don't let the complexity scare you. While the science behind metamaterials might seem complicated, the basic idea is quite simple. It's all about taking advantage of the laws of physics to create materials with unprecedented capabilities. So, metamaterials are not just science fiction anymore. They are real, and they are here to change the world. But how do metamaterials change their shape and properties, you ask? Let's dive deeper. At its core, the magic of metamaterials lies in their structure. These are not just ordinary materials. They're carefully engineered from the ground up, crafted on a microscopic scale to exhibit properties not found in nature. Let's take a closer look at how they work. Metamaterials are composed of tiny, repeating structures, each one smaller than the wavelength of light. It's these structures that give metamaterials their unique properties. They can be designed to respond to light, sound, or other forms of energy in unusual ways. But the real magic happens when we start to manipulate these structures. By applying different forces or changing the temperature, we can cause the structures to shift and change. This is how metamaterials can dynamically tune their shape and mechanical properties. In essence, we're not just changing the material, we're changing the very building blocks of the material itself. It's like having a Lego set where the bricks can change their shape, size, and even their function on command. Now you might be wondering, what's the practical use of such a material? The potential applications are as vast as they are exciting. Imagine buildings that can withstand the forces of earthquakes by dynamically adjusting their structure, or clothes that can adapt to weather conditions, that becoming warmer as the temperature drops or cooler as it rises. Consider the medical field, where devices could be designed to change shape to suit individual patient needs. A heart stent, for example, could be customized in real time during surgery for a perfect fit. The possibilities are endless, limited only by our imagination and our ability to design and control these extraordinary materials. Incredibly, we can now design our own shape-shifting and programmable matter tailored to a unique application. That's the power of metamaterials. As we stand on the brink of this new era in materials science, what does the future look like? Peering into this exciting new realm, we see a landscape filled with potential applications of metamaterials. These materials are not confined by the limitations of nature, but rather they are defined by the limitless bounds of our imagination. Imagine bridges that can self-heal from cracks or buildings that can change their shape to withstand earthquakes. Picture wearable devices that can morph to fit any body shape or prosthetics that can adapt to the wearer's needs in real time. These are not just visions of a distant future, they are the tangible possibilities that metamaterials bring to our doorstep. But as with any scientific endeavor, the journey is not without challenges. Scientists are currently wrestling with the task of scaling up the production of these materials. How do we manufacture them in large quantities without compromising their unique properties? And how do we ensure they are safe for use in diverse applications? These are the questions driving research at the frontiers of materials science today. Moreover, the potential impact of metamaterials extends beyond the realm of physical structures. Think of the telecom industry, where metamaterials could lead to super-efficient antennas, or the medical field, where they could revolutionize imaging techniques. Even in the domain of clean energy, metamaterials hold the promise of highly efficient solar cells and wind turbines. It's important to remember that the metamaterial revolution isn't just about the creation of new materials. It's about a fundamental shift in how we think about materials. It's about moving from a world where we are bound by the properties of the materials we find in nature to a world where we design materials with the properties we desire. Indeed, the future of materials science is not just about understanding what materials are, but also about reimagining what they can be. And with metamaterials, the future is here.
Cherish knowledge, give a thumbs up, hit subscribe, explore science and tech.